So there was a request to basically asking how you do a EM simulation properly for a capacitor. So I'm going to show that in this video, and also about how you can actually import GDS files, especially the RF frame, the frame and the RF pads. Now before I go into that, I also want to make a remark on the review 3. Now there was mixed set of questions from students. Now if you, so basically in the review 3 you had to do the EM simulations, right? So all of your lumped or like closed form models, which is like lumped elements, either capacitors from the P15 library and the inductors from the P15 library, has to be replaced by EM models. Now if you, so in this case you can actually replace, so except for the transistor, you can replace these junctions, everything including the inductor, capacitors, transmission lines, up to pretty much here. You can't really EM the voltage source. It has to come as separate port from outside in one EM. But when you do that, you might run into problems like having a different S21 curve to what you originally had. So that's why I suggested to do EM simulations for example, the cap separately, this inductor separately, and this cap separately, and then you do a full EM for this section afterwards. Now but if you're brave enough, you might be okay, you might go ahead and do a EM for each stage, and it might work, it might not work. I think if you don't get the inductors at least right, it won't really work. Now so if you don't have it meeting the specs perfectly, but it is close enough, that's okay for the review 3. Or it is at least having certain gain, like maybe it's detuned, but that's still okay for review 3. It's, well, obviously it's better, it's best if you meet the spec, but if you don't, that's fine. So in the review, because when you go to review 4, you have to do the layout, and when you do the layout, you might have to re-EM it, which means in the review 4 is where I expect you to meet all the specs, or whatever the specs that you can meet in the review 4. So in the review 3, main idea is to do the EMs and then sort of arrange the components inside the frame and include the RF pads in the layout. Maybe so in the review 3, even if you don't show the layout, that's fine, but if a student might choose to show the layout, if they do, that's actually better, because that gives me an idea that you actually considering the EM and the layout interchangeably. Now before I do the EM part for this capacitor, maybe I'll do an EM for this capacitor. So what I would do, I will get this into a sub-circuit. I'll say so I have to create a new schematic. I'll say stage 1 cap 2, because there was another capped. Okay, so that's the stage 1 cap 2, and then I can paste this here. Now I need to be, so this is 100 by 100 cap, that's 10 by 10, that's 10 by 10, that's an empty dollar, so that should be okay. So I can do the cap by itself, but I thought I'll show it like all together. Now I'll include a port here. So before I do anything, I'll actually run this. So this was my S parameters I got before running the EM. Just save it, freeze it. Then I'll go to stage 1 cap. So let's have a look at the layout of this. It's here and there, but maybe I can snap everything. Okay, now you'll notice easily that this line I prefer it to be longer, this line I prefer it longer, and this T junction itself is not really perfect because you have much wider width here, this is smaller. So let's go back to the schematic, and then let's see why it is not really. So if you go to second, so I can actually do this. Let's try this. So it will take the width at the connecting stage, and then if you go back to the layout, that's fine. So what it says, width at 1 when I did it, so let me just snap it again. When I did it width at 1, what it did basically is look at, so what I did was go into properties, go into second, and then instead of W1 I say width at 1, so it looks at the connecting port at port 1 and it takes that width in. So it can only do that if this element is intelligent enough to provide that width to here. Now that's why you had issues in your simulations earlier. A capacitor, like I think when you change the P15 capacitor, the S parameter curves weren't really coming up once you simulate it. That's because it wasn't intelligent enough, that maybe the adjacent elements wasn't intelligent enough to provide the width, or the capacitor wasn't intelligent enough, something or other. Okay, so we have this setup, but I think I prefer, if I'm doing this, to have this coming up to here, that means I have to actually extend this up to here, because ideally if I'm putting a port, I want my EM simulations to not like be within the ports. So what I meant by that was I want to extend this point, so maybe to here, so it's about 38, so I will have to add 38 more to this point length, so that's going to be let's make it 50. So 38 plus 10 is 48, so I'm going to make it 50, and then if I go back here and then snap it, okay, so I have the cap sort of. Okay, now when I do that, I need to remember I have to do that in the LNA as well, because I don't want, so we had it in memory. We'll see what happens. Normally with the lengths of the lines it doesn't really matter much, but in this case, because this inductor is going to add up to this inductor, because this line length itself is inductive length, there might be a slight change. Let's have a look. But very slight change, so it doesn't really matter much. So now I can, so maybe I'll unfreeze the trace and freeze this new trace. I will go back to stage 1 cap 2 schematic. I have to add extract block, so different ways to add. I will normally do it like here, extract, get it here, and then I will select my, so I think I should do this as give it a name, more sensible name, stage 1 cap 2 EM, and EM extract is the name, that's fine. Axiom, you are familiar with these setups now because we've been doing this in the lab. The idea in the lab was to give you a bit of a feel for it, and then it's not highlighted, so I have to select the elements, so normal steps, model options, enable, so it's okay. Now I can add the extraction, so I should see an EM structure, which is this one. So that's stage 1 cap 2 EM, so I can see that's done. So the next step is to actually look at the mesh. Okay, so no error in meshing, so I'll start simulation. Okay, so because I haven't really, I can simulate this, or I can either go here, start simulation. Should be quick, I think, because it's a very basic cap on VR. So this is called a cap on VR because this one has a capacitor and a VR together. When you do a capacitor, it's the same thing, doesn't really matter. When you do a capacitor, actually you might have another transmission line here, so you need to put ports on this side and that side. So you'll have to wait for the simulation to finish. And also, this is not a sort of a manual EM which you make up your own inductor capacitor, so you don't have to go to the LPF and cloak and uncloak things, which is much convenient when you do EM extractions rather than your manual EMs. Normally, the caps you don't really have to change. It's mainly the inductors you have to change. If I do a manual EM on this capacitor, I would actually simplify this structure. So you see, this simulation is actually taking some time, much longer than I thought to take. I would actually simplify some of the layers, but doesn't really matter. You probably don't worry about it. So usually the cap would actually simulate faster. I think the cap on VR takes a bit more time because of the VR. Now we have the simulation done. There was no errors on the simulation. Now we have to replace pretty much this part with this new sub-circuit which we did. What was that? We can either replace it with this or this, doesn't really matter. But we'll just replace with the schematic. So you just need to make sure you do it properly. So that's your port 1 here, that's my port 2 here, so I didn't have to toggle enable this because I'm using, usually cap simulations are good and close enough. We can check if it is. Yeah, so that was no change at all. So caps very easy to simulate, although it takes time, but simulations are very close to the closed form model, so it's good. Now, so that's how you do a cap. Okay, so I think that will help you guys with the simulation. So this is how you do a cap on VR, and when you do a cap, you do this pretty much the same way. Now what else? Okay, I want to also show you now. So far, if I go to the schematic, my layout is pretty scrap. That's not what you want. You want it to be more. So my layout, this is what we just simulated, this structure, because it takes the EM. Let's rotate this, and then that's my resistor, and that goes to my supply. Okay, so I have the first stage at least coming into shape. Now the other thing I need to do is now see how things fit in the frame and the RF pads. So if I'm doing that, I had to get my RF pads GDSs, similar to what you had in your lab 3. So the way you do it is you go to layout, say libraries, say import GDS2 library, and then I will upload. I already have put the RF pads. I will upload the frame and the DC pads, so you can actually import it into your LNA project. It's pretty much the same. So I will import this. I wonder if I can actually import multiple. Probably I can. No. Okay. So I got. So I should have renamed it, but this is frame, and then I will have to get the DC pads. Okay, so I have the RF pad frame. So if you click on that, you get the RF pad, you get the frame, you get the DC pads. So DC pads here is actually, you have a signal and the ground. So this is for gate biasing, and this is for drain biasing. You can interchange it obviously. Now if you want to change, in your case you have three gate voltages. If you are using a 3-stage, if you are using 2-stage, you have 2 gate voltages. Now I said you guys can have actually individual biasing, so that's, but you need to have a signal and a ground. So maybe this DC pad, I'll actually make it, I'll make a copy of this and I'll modify this. Maybe you guys can have a look at it as well, to be just a 2 pads, because then you can interchangeably use it. DC pads, say V2. Now in here I can go into DC pads V2 and probably so I have to actually modify it in a layout, so I will do it. TLC, it's a 8080 copy, it's a ground. Okay, DC pad V3. So I will get I will get this. Sorry. And then put it in exactly 0 0. That's 0 0. And then I will also get the other one. Oh, maybe I have to, yeah, that's fine. Then I get the other one. Oh, we have to check how far they are. You don't have to do this, it's just me doing for you. I need to check the length between them. I think it's 150, yes. So I put the first one 0 0, so I have to put the second one, just this copy. So I'll put it x150 y0. Okay, that's fine, because it comes, the 0 0 is point is here. For some reason it was Yeah, so we just have to move this. If I go into this is just some extra steps for you. If I select, I can make, so what I will make this a separate, so I will remove the VR because that will be easier for me to handle. So I will remove this VR for now and paste it somewhere else, and I will make sure this one aligns with this one center to center. So this one pretty much aligned, that's okay. If that's the case, I could do it this way, aligns with this one. Okay, so that's the pad, DC pad. So I will save this. Yes, I will export this. So you can, I will export this layout so you guys can import it back. So what I meant by that is that I'll show it to you in the next couple of minutes. So I want to get the frame first. Select all, paste, and then I have to go back to my LNA, and then I go to my layout. I put the frame. Okay, so I put the frame like this. You still have to fit everything, so it's going to be tight fit, but if it's a 2-stage, I think you can do it. Now you'll easily notice this is obviously not the best thing to do. You will have to move this up here and maybe move this, flip it and then move it this way, because otherwise I'll be out of frame. Now I have to get the RF pads too. So if I go to the let me close everything, it's too many windows. So I've got the RF pad, then I will also get the LNA and the inductor LNA. I'll get the RF pad, so I'll need 2 of them. So you'll notice that it has to go here, right? So if I put it here now and then try to select the other elements, very hard, so I'll keep it here, then move this aside. So your transistors, there's a rule that always has to run on the horizontal. Gate has to run horizontally. Now I could do something like that, but I'm going to run into, see, my inductor is going to run into the ground pad, so I have to tune my inductor again, maybe change it differently. So that's why it's important to have the layout when you do the EM, so that it doesn't run into the ground pad. Okay, so this is just my first stage. So if you actually have a 2-stage, I think it's manageable, because then you have the other transistor. If you have 3-stage, maybe you are struggling, but I think I fitted once a 3-stage to frame of 945 in the same band, so it should be fine. That's a lot of effort to do. And then you have another RF pad here, and then you have your DC pads. That's what I was talking initially. Then you have a DC pads, which I was and then I'll go back to coming from, so that's my signal ground for one. So you see, you have to have space for that. And then another DC pad for this is, say, let's say we have, this is for the drains, and then you need to have for gates signal ground. So these signal pads will supply for, say, drains, and these ones for gates. So you need to have 4 DC pads if you have 2-stage, right? So you, and this pins is where the so let me take a photo of this, maybe zoom in. So these pins, I can't put it there, maybe I'll put it in my here. So so when you package this, you will have a package, and then there'll be wires coming from the bonding. So these are called the bonding pads. So there'll be a DC wire out from the outside landing on this, and there'll be two wires pretty much on the signal, ground. These are called wire bonds, and then you have a signal, ground. Sorry, these are DC positive and the ground, DC positive and the ground. So that's how you really actually bond. So this is just a die. This is the die and gets packaged in a, so package in a 2mm, and this is about 945 micrometer by 945. So then if you get a chip, you will notice that the chip will have, like, you know, at the end when you package, once you package, you will have the pads where you surface mount them to a circuit board, and inside it you will have wire bonds like this. So that's what happens once you manufacture it, but we are not going to that stage. But that's why we had put RF pads and DC pads like around here. So I think that should give you good overview on what. So at the end of review 4, I would expect you to have actually pretty much everything fitted here inside this frame, and the layout finalized. And then you need to make sure that when you do the EM for the inductors, capacitors, or whatever the stages in here, that should sort of meet the spec, at least in the review 4. Review 3 spec, meeting the spec, if you meet it, good, but you might still have to do some changes when you go to the full proper layout. So yeah, so bear that in mind. I think that should be good enough for the meeting video.